Hello, welcome to one and all to Tungal online classes. In the previous few months, we have discussed so many chapters. We have completed the part 1 physics. Now, onwards today, we will discuss the part 2. Students, in part 2, the first chapter is mechanical property of solids and mechanical property of fluids. We are leaving those chapters, we will discuss later. Now, today we will start thermal properties of matter, the new chapter. Thermal properties of matter. Mainly in this chapter, we are discussing about the heat, temperature, measurement of heat and some properties when heat of the body increase, what property are changes. Those concepts we are learning one by one. Initially, we will start the theory part, later on we will go for the coaching part. Students, in this chapter, mainly we are discussing about the heat and temperature. Let us go the concept of heat. Concept of heat. Actually, till the 18th century, we have believed that heat was a fluid known as calorie. What it was? Heat was considered was the fluid. It was called as calorie, and the hot substance having more calorie and cold substance has low calorie. But later on, Benjamin rejected this theory of heat, and he said that heat is not a calorie. Instead, heat is the energy. Heat is the energy it converts from one energy to another energy, or simply heat is a form of energy. It can transfer from one body to another body. See here, how to conclude the heat is a form of energy. Heat can be defined in so many ways. To understand the concept of heat, let us take some few general examples and common experience. The common experience is, if you stand near the fire, you can feel warm, right? In same way, if we stand near the ice bath, we can feel the cold, right? I mean, if we stand near the fire, we can feel the warm, and if we stand near the ice bath, we can feel the cold. Simply, heat produces the sensation of hotness or coldness, right? Or you can take the one more general experience. General experience is, let us take the cup of hot tea, right? When cup of hot tea placed on the table, after some time the tea becomes cold. I mean, tea is a system. From system, heat is transferred from system to surrounding due to temperature difference, because the hot tea has more temperature, surrounding has less temperature. Due to difference in temperature, the heat energy can transfer from a hot system to cold system. Or can take the one more general experience. Experience is, let us take a hot body and let us take a cold body. Now, the hot body made physically contact with cold body. Generally, energy will transfer from hot body to cold body. Still, temperature of both systems must be same, right? I mean, what we are going to learn from this, heat is a form of energy which can transfer from one body to another body due to difference in temperature, right? I said two general common experience regarding the heat. What is that? If we stand near the ice, we can feel the cold. If we stand near the fire, we can feel the warm. In one way, I can define the heat here. Heat is a form of energy which produces the sensation of hotness or coldness, right? In second way, how to define? Let us take a hot body and let us take another is a cold body. Both made physically contact. What happens here? Heat can transfer from a hot body to a cold body. Still temperature of both the system remains same. I mean heat is a form of energy, it can transfer from one body to another body due to difference in temperature. Right students? Shall I go the definition of heat? In what way I can define the heat? Heat is a form of energy. It is a form of energy. It is a form of energy. Form of energy which produces sensation of hotness or coldness. Hotness or coldness, or alternating way also can define. It is a form of energy which can transfer from one body to another body due to difference in temperature, that we are calling heat. Generally students, shall I take, I will take this is hot body, this is hot body, shall I take, right? Now I will take this is one more body, let us take it is a cold body, it is a cold body. Now hot body has more temperature, and cold body has less temperature, right? I will make physically contact. Physically contact means, let us take the hot body made physically contact with the cold body, Here what happens? Energy transfer from a hot body to cold body. Still temperature of both the body remains same. Still energy transfer from one system to another system. Simply we can say that heat is simply the form of energy, it can transfer from one form to another form also. Because one more common experience you can take, the kinetic energy can possible to produce the heat energy. Heat also produced due to conversion of one form of energy into another form of energy. How to know? Let us these are the palms of the hand. If the palms of the hand are randomly rubbing, so hands getting kinetic energy. The kinetic energy of moving hand is converted into heat energy. Simply here energy converted from one form to another form. Right thing? See here what happens? It is a hot body, this is a cold body. When they made physically contact, heat will transfer from a hot body to cold body. Due to what? Due to difference in temperature. If there is no difference in temperature, heat won't flow from one system to another system. Right? And here, whatever heat gained by the body, that is taken to be positive, and heat lost by the body, it is taken to be negative. It is convention. How to take the convention? Heat gained by the body is taken to be positive, and heat lost by the body is taken to be negative. Students, heat can measure either in terms of calorie or in terms of joule. See here, the CGS unit of the heat, CGS unit is nothing but calorie. Is calorie. And SI unit of the heat, is nothing but joule. This is joule. See here, in between calorie and heat there is a relation. Here 1 calorie is nearly equal to 4.2 joule. This is what the concept of heat. Now let us go to the concept of temperature. We said that when hot body made physically contact, heat can transfer from one body to another body. Right thing? Let us take the concept of temperature. On this basis, let us see the concept of temperature. See here. temperature. Temperature. We say the definition of it what? It measure the degree, it measure the produces sensation of hotness and coldness, that we are calling heat. Here temperature measure the intensity of hotness and coldness. Simply, temperature is a physical quantity which measure degree of hotness or coldness, or it measure the intensity of degree of hotness and coldness. Simply, how to define temperature? It is a physical quantity. It is a physical quantity. It is a physical quantity which measures intensity or degree, intensity of hotness, or coldness. It means the hot body has more temperature and cold body has less temperature. Here hotness is the degree of hotness. Degree means intensity. How much intensity? Intensity ಅಂದ್ರೆ ತೀವ್ರತೆ. ಟೆಂಪರೇಚರ್ ಏನು ಮೆಜರ್ ಮಾಡ್ತದ? ಒಂದು ವಸ್ತುವಿನ ಹೀಟ್ ಎಷ್ಟು ತೀವ್ರತೆ ಅದ ಅದನ್ನು ಮೆಜರ್ ಮಾಡ್ತದ. ಸಿಂಪ್ಲಿ ವಾಟ್ ಯು ಆರ್ ಕಾಲಿಂಗ್ temperature is a physical quantity which measure the intensity of hotness and coldness, or intensity of hotness or coldness. Right? Simply students, temperature determine whether energy flowing from one body to another body or not. What I am going to say? Temperature measure whether energy flowing from one system to another system or not. That indicates the temperature. How to conclude actually? See here, I will take this is a hot body. This is hot body, right? I will make physically contact with the cold body. This is the cold body. Here what happens? Energy transferred from hot body to cold body because of only it has the temperature T1, it has the temperature T2, right? But if both system having same amount of heat, see here, let us take, I will take this nothing but a hot body, right? It has temperature. For example, I will take this 100 degrees Celsius temperature, right? Again I will take one more body. I will make physically contact. I will make the physically contact. This body also having the same amount of temperature. Both body made physically contact. In this case, there is no transfer of energy. But in this case, it may be the temperature 100 degrees Celsius, it may be 2 degrees Celsius or 0 degrees Celsius. If we made physically contact, definitely heat can flow from hot body to cold body. But in this case, there is no transfer of energy. I mean, temperature indicates whether energy flows from one body to another body or not. In this case, there is no flow. In this case, there is flow. Or can say, temperature measures the average kinetic energy of the system. How temperature will rise? Temperature will rise only when kinetic energy of the system or kinetic energy of the particle will increase, then only the temperature increase. How much kinetic energy increase, that much temperature also increase. Simply, temperature depends on kinetic energy. More the kinetic energy, more the temperature. Lesser the kinetic energy, lesser the amount of the temperature. Simply, temperature is a physical quantity which determines whether the energy flows from one system to another system or not. Or temperature is a physical quantity which measures the intensity or degree of hotness or coldness. Right, students. The temperature measured in so many scales. We have 5 scales to measure the temperature. One is the Celsius scale, second one is the Fahrenheit scale, third one is Kelvin scale, Reaumur scale and Rankine scale. We have 5 scales to measure the temperature. Then how the temperature of the system can measure? Temperature of the system can measure by one more device. Its name is thermometer. Thermometer is the device which measure the temperature of the system. I mean which measure the average kinetic energy of the system. Already I said temperature depends on average kinetic energy. Right. Now let us go for temperature scales, measurement of temperature. We already said that there are 5 systems to measure the temperature. Let us take the few systems only here. Measurement of temperature. See here. Temperature scales or measurement of temperature. Measurement of temperature. Right, students. We said that there are 5 systems to measure the temperature. One is what? First one is Celsius. Celsius scale. Celsius scale. Second one is Fahrenheit scale. Fahrenheit scale. Third one is Kelvin scale. Kelvin scale. Fourth one is Rankine scale. Rankine scale. And fifth one is Reaumur scale. Reaumur scale. There are 5 systems to measure the temperature of a given system. Right. See here, we said that temperature can be measured only on the basis of the device that we are calling thermometer. Every thermometer has 2 scales. One is lower fixed point and upper fixed point. These 2 points how to take? The lower fixed point can taken on the basis of freezing point of the water and upper fixed point can be taken on boiling point of the water. These are the 2 scales. Any scale, any 5 scales can be taken on the basis of the freezing point of the water and boiling point of the water. The freezing point of the water mean the water becomes ice, and upper fixed point boiling mean the water start to boil generally. Right. Any thermometer, so many types of thermometers are available. Any thermometer consists of 2 fixed point, one is a lower fixed point, second one is upper fixed point. Right. Now let us discuss only 3 scales. One is Celsius scale, Fahrenheit scale and Kelvin scale. Right. Look at me here. These 3 scales we discuss in one by one, and how to convert one system of scales into another system of scales here. Shall I go? Already I said that any thermometer consists of 2 scales. See here, this is the thermometer. Shall I take? It is a thermometer. Right. Thermometer is there. This is the lower fixed point. Lower fixed point. And what about this? Upper fixed point. Right. Lower fixed point can be taken on freezing point of the water. Upper fixed point can be taken on boiling point of the water. Now, shall I go for directly the Celsius scale? First scale, shall I see? Celsius scale. Celsius scale. Right. Students, in Celsius scales also we have 2 fixed point. One is a lower fixed point, second one is upper fixed point. And the Celsius can be represented like this. Celsius can be represented like this, right? In a Celsius system, Celsius scale, lower fixed point can be taken on the basis of freezing point of the water. The water freezes at 0 degree Celsius. Water freezes at 0 degree Celsius is nothing but lower fixed point, and water boils at 100 degree Celsius. This is upper fixed point, right? In between lower fixed point and upper fixed point, we have made 100 divisions. One division is equal to 1 degree Celsius. In between these two, lower fixed point and upper fixed point, how many divisions are available? 100 divisions are available. Imagine, these are the 100 divisions. One division must be equal to 1 degree Celsius. Then how to take this? How to take the formula to measure the Celsius scale? See here. To measure the Celsius scale here, one division is equal to total division is equal to 100. In between lower fixed point and upper fixed point. To measure the Celsius scale, we have formula here. The formula is theta C, temperature in degree Celsius, minus lower fixed point divided by total number of divisions. How many total number of divisions? 100 is the total number of divisions. What is theta C? Temperature in Celsius, minus indicates lower fixed point and total number of divisions. Look at me here. Shall I go directly formula for this? Theta C minus of lower fixed point is how much? 0. How many divisions are there? 100 divisions are there. This is what? To measure temperature in a Celsius scale. To measure the temperature in Celsius scale. Here what is the system here? It consists of lower fixed point, upper fixed point, in between them 100 divisions are there. Similarly, the Fahrenheit system also is there. In Fahrenheit scale, how the scales can be taken? Shall I go? Remember this formula. Look at it. In Fahrenheit scale, second system of Fahrenheit scale. Fahrenheit scale, right? Let us take any one thermometer will take. Again, shall I take this is the thermometer? Thermometer will take, right? What you can take? One is lower fixed point. Already I said that any thermometer consists of two fixed point. One is a lower fixed point and second one is upper fixed point. Upper fixed point. Right. Here how to take? How to take lower fixed point and upper fixed point? In Fahrenheit scale, lower fixed point can be taken on freezing point of water at 32 Fahrenheit. I mean water freezes at 32 Fahrenheit. And upper fixed point can be taken on boiling point of water at 212 Fahrenheit. Here water freezes at 32 Fahrenheit in this cell and water boils at 212 Fahrenheit. In between lower fixed point and upper fixed point. In between lower fixed point and upper fixed point. How many divisions are there? In between lower fixed point and upper fixed point, here 180 divisions are made. These are 180 divisions. Remember, in between lower fixed point and upper fixed point, how many divisions are there? 180 divisions are available. One division equal to 1 Fahrenheit here. One division must be equal to 1 Fahrenheit. Shall we see here how to take the formula? Already I said that theta F is nothing but the temperature in Fahrenheit. Right. Minus lower fixed point divided by total number of divisions. simply minus it. How many are there? In between them 180. 212 minus 32 is equal to 180 divisions. One division must be equal to 1 Fahrenheit. Now shall you see your formula? What formula becomes? Theta is nothing but temperature in Fahrenheit. Lower fixed point is 32. Total divisions how much? 180. 180, which is the formula for Fahrenheit. What was the formula for degree Celsius? Theta C minus 0 divided by how much? It is 100. It is for degree Celsius. I mean Celsius scale. For Fahrenheit scale, like this. Then one more Kelvin scale is there. Kelvin scale. Shall I say Kelvin scale here only directly? Look at me. For Kelvin scale, how to take? Kelvin scale. Right. In Kelvin scale, what happen again? We have the thermometer. Look at me, it is a thermometer. Available thermometer available. This is what? Lower fixed point. This one is upper fixed point. Upper fixed point. The lower fixed point here, how to take? Lower fixed point. Right. Lower fixed point can be taken on freezing point of the water at 273.15 Kelvin. 273.15 Kelvin. This is the lower fixed point in Kelvin scale. How to take upper fixed point? Upper fixed point can be taken on boiling point of the water at 373.15 Kelvin. Are you following, students? In Kelvin scale, what happened? Lower fixed point can be taken on freezing point of the water at 273.15 Kelvin. And boiling point of the water can be taken as upper fixed point. That temperature is at 373.15 Kelvin. In between lower fixed point and upper fixed point, we have 100 divisions. Here 100 divisions are there. Shall I take this 100 divisions? Right. Then again formula for this. Shall I take formula for this? Theta K is nothing but Kelvin. Lower fixed point. Lower fixed point divided by how much? Total number of divisions. Then for Kelvin scale, what is the formula? For Kelvin scale, theta K minus theta K. Theta K. Lower fixed point is how much? 273.15. Total number of divisions how much? 100. This is Kelvin formula. I mean, to measure the temperature in Celsius, we are going to use this formula. For Fahrenheit scale, we are going to use this formula, and for Fahrenheit, for Kelvin scale, we have to use this formula. So remaining to all the Rankine scale and Riemann scale, it is for not necessary to our syllabus. Leave them, Rankine scale and Riemann scale. Now students, from Celsius to Fahrenheit or from Fahrenheit to Kelvin scale, we can convert the temperature. Mean the Celsius temperature 27 degree can be converted into Fahrenheit, or 300 Kelvin can be converted into Celsius, or 300 Kelvin can be converted into Kelvin, or 300 Kelvin also converted into Fahrenheit. We can convert from one system of temperature into another system of temperature. Generally the two systems are famous. One is the Celsius scale and second one is the Kelvin scale. Generally, more you are using the system of temperature is Celsius scale and Kelvin scale. Right. Then now let us see how to convert one system of temperature into another system of temperature. Shall I see that? Kelvin into Fahrenheit or Fahrenheit into Celsius, Fahrenheit into Kelvin, or can convert from Kelvin to Fahrenheit. Vice versa can convert. Shall we see conversion of one temperature, one system of temperature into another system of temperature? Look at here. How to convert? Right students, how to convert? Conversion of system of temperatures or conversion of temperature scales, right. See here I am writing three systems. First two system I will write in degree Celsius. What was the formula? In degree Celsius, theta c minus 0 whole divided by how much? 100. It is Celsius. What about Fahrenheit? Fahrenheit theta f minus of how much? 32 whole divided by how much? 180. Simply I want to convert Celsius into Fahrenheit. How to convert? I want to convert Celsius system into Fahrenheit system. What to do? Shall I write it directly? How to convert? Just I am comparing these two systems. We can convert Celsius into Fahrenheit and Fahrenheit into Celsius. No matter here. Shall I write it directly? Theta c minus 0 whole divided by how much? 100 equal to, just I am going to compare theta f minus 32 whole divided by how much? 180. Right. Shall I simplify this? Theta c divided by how much? 5 equal to theta f minus of 32 divided by how much? 9. Right. You can do like this. Now again we have the formula. Theta f equal to, or you can write theta c or you can write the theta f, no matter. Look at me how to write. How to write this value? Theta c equal to 5 divided by 9 into bracket theta f minus 32. Right. If he has given the Fahrenheit, we can convert into degree Celsius. Right. Or one more formula you can use directly from this. How to do? Theta f minus 32 equal to, from this how to write? 9 by 5 into theta c. Right. You can write like this also. We can convert one system of temperature into another system of temperature by using these two formulas. Right. Similarly, we can convert Celsius into Kelvin also. Celsius into Kelvin. To convert Celsius into Kelvin, what to do? Again we have the two systems. Right. We have the two systems. One is what? Celsius scale is there. Theta c minus 0 divided by how much? 100. Right. It is Celsius temperature. Then what about Kelvin? Kelvin is like this. Theta k minus of how much? 273.15 whole divided by how much? 100. It is what? Kelvin scale. Again I am going to compare both the system. Theta c whole divided by 100 equal to theta k minus 273.15 whole divided by how much? 100. Right students? Here 100 will cancel. What is remaining? Theta c equal to how much? Theta k minus 273.15. If Celsius is given, we can calculate Kelvin, or you can write this formula like this also. Shall I write this formula in what way? Degree Celsius equal to how much? Or theta k equal to how much? Theta k equal to degree Celsius plus how much? 273.15 degree Kelvin. I mean, if the given degree Celsius, we can convert into Kelvin using this formula, or using this formula, if he has given the Fahrenheit, you can convert into degree Celsius. This is, or you can convert like this also. We can convert from Fahrenheit into Kelvin also. You can convert. Just try it, students. But one is that at a common temperature, both of Fahrenheit and Celsius have same temperature. What I am going to say here? The Celsius scale and Fahrenheit scale has the same reading at a particular temperature. At the same temperature, both having same reading. That will check. See here. We know that the formula for degree Celsius, what was it is? Theta C minus 0 whole divided by how much? 100, right? For Kelvins, for Fahrenheit, what it is? Theta F minus of how much? 32 whole divided by how much? 180, right? Now let us compare both scale. I am going to compare here. Comparison mean what? Directly theta C divided by how much? 100 equal to theta F minus of 32 whole divided by 180. We can write like this also. Theta C whole divided by 5 equal to theta F minus of 32 whole divided by, what are going to say? Both the scales having same reading at a particular temperature. At a particular temperature mean, shall us here? Let us take theta C equal to theta F equal to theta I will take. ಅಂದ್ರೆ ಎರಡು ಸಿಸ್ಟಮ್ का ಸೇಮ್ ರೀಡಿಂಗ್ ಅದ ಯಾವ ಟೆಂಪರೇಚರ್ ಒಳಗ ಇವೆರಡು ಸಿಸ್ಟಮ್ ಕ್ರಿ ಸೇಮ್ ರೀಡಿಂಗ್ ಅದ ಯಾವ ಟೆಂಪರೇಚರ್ ಒಳಗ ತಗೋತೀನಿ ನಾನು ಥೀಟಾ ಸಿ ಈಕ್ವಲ್ ಟು ಥೀಟಾ ಎಫ್ ಈಕ್ವಲ್ ಟು ಥೀಟಾ ಹಿಂಗೆ ತಗೋತೀನಿ ನಾನು ತಗೊಳ್ಳೋಣ್ರಿ. ಲೆಟ್ ಅಸ್ ಗೋ ಸಿ ಹಿಯರ್ theta c can be replaced by theta 5 keep it up same equal to theta f can be replaced by theta 32 keep it up same and 9 also keep it up same, no matter, right? Again from this what we can do, see here how to do directly from this what we can say, see here 9 theta equal to 5 into bracket theta minus 32, right? Solve all these things. What are getting? Theta equal to minus 40 degrees Celsius or 40. I mean both the system having same reading. Same reading what? Both the system having same reading at a particular temperature. What temperature? Minus 40 degrees Celsius. At minus 40 degrees Celsius, both having same reading. What this is? One is Celsius, second one is Fahrenheit. After this student, we are going to discuss ideal gas equation and absolute temperature. Absolute temperature is very important in physics and ideal gas equation. The both concepts we will study in the next class. Thank you students.